Many instrument approaches are based on nav aids that do not provide glide slope information. They are classified as non-precision approaches. There are two general types of VOR approaches. Some have the nav aid located at the airport so that your final approach segment ends at the VOR. Others have the VOR located away from the airport. Your final approach segment is either to or from the station and ends at the runway. Another consideration with non-precision approaches is whether you can land straight in from the approach or if you need to circle to land. Some approaches have the final segment closely aligned with the runway. In most cases, you can make a straight-in landing from these approaches. When the final segment does not meet the criteria for a straight-in landing, a procedure called a circle-to-land maneuver is usually required to align your aircraft with the runway. Another concern is whether or not DME is available or required for the approach. Since there is no such thing as a typical VOR approach, you must study each chart before using it. With that in mind, let's look at the VOR runway 31 approach into St. Cloud, Minnesota. Your present position is on the feeder route from Daly intersection. Minneapolis Center has cleared you for the approach, and you have received the current altimeter setting from St. Cloud Unicom. The minimum altitude for this feeder route is 3,000 feet. Your inbound course to St. Cloud is 222 degrees. Once you're established on the course inbound to St. Cloud, and if your aircraft is equipped with dual VOR receivers, set both to the St. Cloud VOR and identify the station. In this example, the number 1 nav is being used to fly to the VOR, and the number 2 receiver is set to the outbound course from the initial approach fix. As you pass over the station, make a left turn to intercept the radial. The profile view shows that once you're established on the outbound course, you can descend to 2,700 feet and complete your procedure turn at that altitude. The procedure turn must be completed no further than 10 nautical miles from the VOR. With DME equipment, you can easily keep track of your distance from the station. Without DME equipment, a 2-minute outbound leg is recommended for most light single-engine airplanes. Of course, you may need to adjust this time based on your ground speed. The procedure turn is completed by flying 073 degrees for 1 minute, then making a 180-degree right turn to a heading of 253 degrees. During this procedure, set the VOR indicator to the inbound course of 298 degrees. When the CDI begins to center, turn right to intercept the final approach course and adjust your heading to keep the needle centered. You may now begin your descent to 1,480 feet. Note that if you are unable to obtain a local altimeter setting and must rely on the one provided by the Princeton Flight Service Station, you cannot descend below 1,560 feet. Also, notice that this approach does not have timing information. Since the nav aid is located on the field, it is the missed approach point. Now let's look at another chart that has timing information. Many VOR approaches require you to determine the missed approach point through timing. In this example, if DME is unavailable, you should begin timing once you reach the final approach fix at Maddie intersection. At a ground speed of 90 knots, you'll reach the missed approach point in 3 minutes and 24 seconds. Now let's go back to your position on final approach into St. Cloud. Although DME is not required for this approach, you'll be able to descend to a lower MDA if you have the equipment. If you can identify the 1.8-mile DME fix, you're authorized to use a minimum descent altitude of 1,420 feet. Without the 1.8-mile DME fix, the MDA is 1,480 feet. Once you reach the MDA, you may not continue the descent unless you have the prescribed flight visibility and required visual references in sight. Furthermore, you must be in a position that allows you to descend to landing at a normal rate. If you're unable to identify the runway environment upon reaching the missed approach point, you must immediately execute a missed approach. The missed approach procedure calls for a climb to 2,700 feet, then a right turn direct to the St. Cloud VOR DME. If you reach the VOR prior to receiving an additional clearance, you must enter the depicted holding pattern. Although DME was not mandatory for the flight into St. Cloud, many VOR approaches require DME, such as the VOR DME runway 28 right approach at Billings, Montana. When DME is required, it is indicated in the chart heading. The plan view shows that in addition to the procedure turn, either of the two 16-mile DME arcs can be used as the initial approach segment. For this approach, DME is required to identify the initial approach fix, final approach fix, and the missed approach point. Likewise, timing information is not given since the missed approach point is identified by DME.
The next type of instrument approach we'll consider uses navigation signals transmitted from a non-directional radio beacon. These signals are displayed on your ADF indicator and are used to fly NDB approaches. An NDB approach is classified as non-precision since it does not provide glide slope information. Your ability to fly this type of procedure gives you access to hundreds of airports not served by VHF equipment. You'll also find that NDB approaches are frequently available at airports that already have ILS and VOR approaches. For that reason, they are often considered backup procedures, since they provide an alternate means of descending to the airport in case of VHF navigation failure. An ILS approach procedure may incorporate a compass locator at the outer marker. At many airports, this same nav aid is used for the NDB approach. In this case, the station is located away from the airport, which requires a timed approach. At other locations, the NDB is positioned at the airport, where it normally becomes the missed approach point. Now let's use your knowledge of ADF to fly the NDB runway 27 approach into Henry County Municipal Airport at Newcastle, Indiana. By carefully studying the chart, you'll notice that this procedure is not authorized at night. You'll also see that this particular approach does not provide timing information for determining the missed approach point. Since the NDB is located at the airport, the missed approach point is at the station. Let's pick up the flight as you near Nudo intersection with a clearance from Indianapolis Center to fly the NDB runway 27 approach. Henry County Unicom has given you the current weather and altimeter setting. With a movable card ADF, set your current heading on the azimuth index. You'll know you're at Nudo when the needle points to the 107-degree magnetic bearing shown on the approach chart. If you have a fixed card ADF indicator, you must add your magnetic heading to the relative bearing to find the magnetic bearing to the station. If your magnetic heading is 081 degrees and the magnetic bearing to the station at the intersection is 107 degrees, your indicator should read 026 degrees when you reach Nudo. Notice how this is the same 26-degree relative bearing that you get with a movable card indicator. Once you're established on the feeder route and are cleared for the approach, you can descend to 2,700 feet. During this segment, you should find the combination of magnetic heading and relative bearing needed to maintain the 107-degree magnetic bearing to the station. After reaching the NDB, you need to turn right slightly and track outbound on the 112-degree magnetic bearing from the station. Fly the outbound leg for approximately 2 minutes before beginning the procedure turn. Adjust this time as necessary to remain within 10 nautical miles of the nav aid. The minimum altitude for the procedure turn is 2,700 feet, which is the same altitude you were at for the feeder route. To perform the procedure turn, turn left to 067 degrees for 1 minute. Then make a 180-degree standard rate turn to a heading of 247 degrees. If you fly the procedure as charted, you will intercept the inbound course at a 45-degree angle. If you're using a fixed card ADF, course interception is shown when the needle points to a 45-degree relative bearing. On the other hand, with a movable card ADF, you set the heading for the second half of the procedure turn under the top index. When you reach the 45-degree intercept angle, the needle points to the 292-degree magnetic bearing to the station. In actual practice, you'll lead the course interception to roll out on the inbound bearing. You can initiate a descent to the minimum descent altitude once you're established on the inbound course. Determining the MDA involves a couple of steps. Since the approach is for a straight-in landing to runway 27, these minimums apply. Because you were provided a local altimeter setting, you can use the lower MDA. As you near the missed approach point, there are many things to consider. For this particular approach, you know that the runway is left of the NDB. So, as you scan for the runway, you must consider your heading as well as the actual location of the airport in relation to the final approach course. If you enter VFR conditions, maintain a normal scan for other traffic. This is particularly important at an uncontrolled airport. In any case, don't descend below the MDA until you're in a position to make a normal approach and landing. If you reach the NDB without positively identifying the runway environment, or if you are not in a position to make a normal approach and landing, you must execute the published missed approach procedure. The missed approach calls for a climb to 2,700 feet, then a left turn direct to Newcastle NDB, and hold. Another type of instrument approach we'll look at uses navigation signals transmitted from a series of satellites. A GPS receiver determines its position in terms of latitude and longitude by knowing the precise location of each satellite and accurately measuring the time a signal takes to travel to the receiver. A minimum of 3 satellites is required for lateral guidance, while 4 are needed for both lateral and vertical guidance. The signals are displayed on a conventional VOR indicator or a digital indicator and are used to fly non-precision, non-localizer instrument approach procedures. With this in mind, let's take a look at how GPS is used to fly a non-precision instrument approach. Because there are a large number of GPS receivers available and each displays position and navigation information differently, you must be thoroughly familiar with the specific equipment installed in your aircraft, as well as its limitations. To fly a GPS approach, there must be a published procedure, and the approach must be retrievable from your GPS database. The database contains waypoints representing all fixes on the approach and displays these points in the same sequence as they are presented on the chart. If a final approach fix or step-down fix is not named in the approach procedure, a sensor final approach fix is established at least 4 nautical miles from the missed approach point. These sensor fixes are identified in the database and appear on Jeppesen charts, but do not appear on NOS approach charts. Flying a GPS procedure is identical to flying a traditional approach. The same approach track is flown and the same minimums apply. The benefit of GPS is that approaches can be developed at airports that do not have the ground-based equipment necessary for a conventional approach. For example, this approach at Frederick, Maryland, is based entirely on GPS. In this situation, the approach procedure is comprised of several fixes that are contained in a GPS database. As you practice, you'll find that using GPS equipment to fly instrument approach procedures is as simple as navigating with traditional equipment. Although VOR and NDB approaches do not have the precision and lower minimums provided by an ILS, they are still an excellent way to descend to an airport in IFR conditions.